Imagine you keep adding fractions. 1 plus 1 over root 2 plus 1 over root 3 and so on all the way to 1 over root n. The sum grows. But does it grow forever? Or is it secretly trapped below a boundary? The answer is yes, it is always less than 2 root n, no matter how large n gets. Today we prove it, step by step, from scratch. The entire proof rests on one simple observation. Root k is greater than root k minus 1. This is obvious, a bigger number under a square root gives a bigger result. But watch what we do with it. If root k is greater than root k minus 1, then adding root k to both sides keeps the inequality true. So root k plus root k is greater than root k minus 1 plus root k. The left side simplifies to 2 root k. So now we have 2 root k is greater than root k minus 1 plus root k. Now we flip both sides. When you flip a greater than inequality, the sign reverses. So 1 over 2 root k is less than 1 over the quantity root k minus 1 plus root k. Now we rationalize the right side by multiplying the numerator and denominator by root k minus 1. This gives us 1 over 2 root k is less than root k minus 1, all divided by the product of root k minus 1 plus root k and root k minus 1. Here we use the identity. A plus b times a minus b equals a squared minus b squared. So the denominator becomes root k squared minus root k minus 1 squared. Root k squared is k. Root k minus 1 squared is k minus 1. So k minus open bracket k minus 1 close bracket equals k minus k plus 1, which equals 1. The entire denominator collapses to 1. So we get 1 over 2 root k is less than root k minus 1. Let us write this cleanly. 1 over root k is less than 2 times open bracket root k minus 1 close bracket. This is our core inequality. Now we are going to sum both sides. We sum both sides from k equals 1 to n. The left side becomes the sum of 1 over root k, from k equals 1 to n. The right side becomes the sum of 2 times root k minus 1, from k equals 1 to n. Let us expand the right side term by term. We get 2 times open bracket root 1 minus root 0 plus root 2 minus root 1 plus root 3 minus root 2, and so on all the way to root n minus 1 close bracket. Look carefully at this expansion. Almost everything cancels. Negative root 1 cancels with positive root 1. Negative root 2 cancels with positive root 2. This keeps happening all the way through. This is called a telescoping sum. After all cancellations, only 2 terms survive, negative root 0 at the start and positive root n at the end. Root 0 is 0. So the entire right side collapses to 2 times root n. And that gives us exactly what we wanted to prove. 1 plus 1 over root 2 plus 1 over root 3 plus 1 over root n is less than 2 root n. The inequality holds for all values of n. Proved. This is the beauty of a telescoping argument. A long and scary-looking sum just vanishes, term by term, leaving behind something clean and simple. We started with one small observation, root k is greater than root k minus 1, and built an entire proof from it. If this video helped you, like and subscribe. Drop a comment if you want to see more inequality proofs like this. See you in the next one.